Continuing with chapter Unit 9, Math 1 Study Guide. Graph and label the points, determine if the triangle is equilateral, isosceles, or scalene. So we're going to say 2, 2. Here's 2, 2. That's point X. Negative 2, negative 1. That's Y. Negative 2, 6. 1, 2, 3, 4, 5, and 6. And that is Z. So I got to determine the length of the sides here. Okay. So this one is 1, 2, 3, 4, 5, 6, 7. Okay. For this one here, I'm going to use Pythagorean Theorem to figure it out. So that's 1, 2, 3, 4. 1, 2, 3. Okay, so I'm trying to find that side. It's going to be, so yx is equal to 4 squared plus 3 squared, which equals 16 plus 9, which equals 25. Okay. So I take the square root of that, so it equals 5. Okay. So this piece is 5, and this is going to be 1, 2, 3, 4. 1, 2, 3, 4. So 4 over 4. And you can tell already, since the sides are different, it's probably going to be different, but we'll test just to be sure. So this is ZX, and let's actually do the whole formula so we have the C's in there. 4 squared plus 4 squared, C squared equals 16 plus 16. Take the square root of both sides, and C equals the square root of 32. Well, that's not going to be 25. Okay, that's a decimal. It's right around 5. That's 5.6. So we can see all the sides are different, so that thing is scalene. 15. Graph and label triangle ABC with the given vertices. Calculate the perimeter and the area. Okay. So negative 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Negative 4, 5, 1, 2, 3, 4, 5. 1, negative 7. 1, 2, 3, 4, 5, 6, and 7. Okay. So the area should be pretty easy. It's just base times height. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That side's 12. 1, 2, 3, 4, 5. Okay, so the area is equal to 1/2 12 times 5. So the area is 30. Okay, now for perimeter, I need to find this missing side. So before I can do that, I got to use Pythagorean Theorem to find the missing side. So let's say 12 squared plus 5 squared equals C squared. That's 144 plus 25 equals C squared. 169 equals C squared. Take the square root of both sides, and this side equals 13. So kind of cutting this up, my perimeter is equal to 12 plus 13 plus 5. All right. So my perimeter is 30. Quadrilateral has given vertices. Determine the most precise name of the quadrilateral. So 0, 0, 4, 0, 1, 2, 3, 4, 3, 2, 1, 2, 3, 2, and negative 1, 2. So that's right here. Okay. So I draw this thing out. Okay. Well, it's pretty obvious that this side and this side aren't parallel. I can check the slopes. That's up 2 over 1. This is up 2 back 1. So those slopes are not parallel. They're not the same. Okay. So that tells me it's not a parallelogram. These both have slopes of 0. Okay. So there's one set of parallel lines, and that is a trapezoid. Last question. Prove that it's a square by using the distance formula and the slope. Okay, but I'll take Pythagorean theorem either way. But we'll use the distance formula this time. So first of all, let's determine if it's a parallelogram. So let's look at slope. So we're going to go check the slopes of AB, 1, 2, 3, 1, 2, 3. So that's up 3 over 3. So I'm going to list my slopes here. Is up 3 over 3. Then this one needs to be the same. That's going to be 1, 2, 3, 1, 2. Yeah, that's the same. So DC equals 3 over 3. Okay. And reducing that down, just so I have something to compare here in a second. Okay. Now let's go over here. Now you got to be careful as I'm going down. So it's down 3 over 3 for AD. Down 3 over 3. So that's negative 1 over 1. This is down 3 over 3 also. Okay, so the significance here is the opposite sides have the same slope, so they are parallel, meaning it is a square. Parallelogram, sorry. Now the fact that the slopes are opposite reciprocals, meaning that they're flipped upside down. Now these are all ones, but I mean like if I had like 3/4 and negative 4/3, those would be perpendicular lines, meaning they cross at a 90-degree angle. So that means these angles right here are 90 degrees. They're 90 degrees. Okay, so that means it is at least a rectangle at this point. Okay, because we've proven opposite sides parallel makes it a parallelogram. We've proven 90-degree angle, so that makes it a triangle, sorry, a rectangle or a square. But the question is, how do I prove it's a square? You need to use the distance formula. Well, if I do this, you can see that I have all the same numbers. Everything involves a 3. So, I said I was going to do the distance formula, but it's really the same thing. Just using Pythagorean Theorem, this is 3 and 3, and all of these triangles that I'm going to create for distance are 3 and 3, meaning this is going to be the same thing. Okay, so that is the square. All the sides are congruent. It's 4 right angles, and opposite sides are parallel.